Right, yeah, it's got a lot to live up to now. But I'm going to start because I'm going to take a 360 photo because it'd be rude not to. So, here's your chance to do something stupid. Ready, 1, 2, 3. It seems to be, I have to do this on every single conference I've done. Anyway, right. Okay, let's get going. Right, with React VR, we at Oculus are building on the React tagline of learn once, write everywhere. And really, we're bringing it to another dimension. So I'm going to consider this as a continuation of the React and render everything policy that seems to be the trend at the moment. So my name is Mike Armstrong. I'm a software engineer with Oculus. I work full-time on supporting React VR. To give you, as Brent mentioned, to give you some perspective on how I see this problem space. I worked in the games industry for many years. I focused on tools and technology there. So it's slightly different from the web background of many of you, or sort of the React background many of you are coming from. I've been lucky enough to contribute on some very high-profile titles in Quake Wars, Uncharted, and Last Guardian. In this talk, I'll start with the problem and what is being solved with React VR, and I'll take you through how Oculus is using this framework, and then a bit more deeper into the React VR implementation. And with this, you'll get an idea how the framework works, and you'll be able to use that and play that to your advantage. Finally, I'll cover some of the questions that I've been asked and the best practices that have come up since we've open sourced our web runtime at F8. So that's why we've built this framework. VR development should be for everyone. It's a bold statement. It's one I really stand by, and it's others and many others too. VR is a transformative technology, and right now its core driver is games. Games are very important, and they often push the technologies forward. But also there's the serious stuff, the news, the education and travel experiences. These are so important to VR, and I really want to see more of these. In my opinion, these are the key to VR everywhere. And so we need everyone to be able to create them with an environment that supports the more frequent release sort of cadence. However, VR is hard, and the content is there, but the barrier is really hard, or really high. And it's a challenge to make use of the wealth of the beautiful 360 photos and videos available. Even using 3JS involves pages of code to create very simple scenes. To get new VR experiences, we want developers to experiment. And to help them do that, we want developers to use known technologies. So, I'm going to do a little survey here and see how it works out. But out in the audience, who wants to create a VR experience? That's pretty good. I'm pretty satisfied with that. But at the end of this talk, I think I'd like everyone to be able to have a go. I'll give you some instructions. Now, VR requires interaction, and interaction requires a UI. We know UI development is hard. A good UI sort of empathizes with users, and ultimately people are complex. So guidelines are a great start, but it always comes down to the compromise between the slick, animated looks and immediacy. What we've learned is iteration is paramount to the best interfaces. And now we put them together. It's really not obvious, but that new dimension causes so much additional complexity. Misuse this dimension, get this wrong, and you can easily make people feel unwell. So therefore, we need iteration on device in VR to create the best experiences. So in our pursuit to help improve VR development, we have our goals. We want to reduce developer complexity through the use of common tools and common languages. Iteration is a prime concern, but we also need to see this feedback in real time on device. And this is where React, and for us actually, React Native fits in. React VR brings modern web technologies to VR with tool chains that many people are familiar with. So let's go through what we bring with React VR. It takes the 2D basics required to build typical 2D. These are the view, the text, the images that you're all very familiar with. And then we expand them with our own 3D views to provide support for models, lights, and panos that are required by many VR experiences. But we also supplement those with the common multimedia types of VR, and that's video, audio, and positional sounds. With these with these components and interactions on them, an amazing amount of VR applications can be accomplished. All the components are presented to you, the developer, in a simple, familiar React way. So let's have a look at the code eventually. So hopefully you can all see this, but it's very Reacty. This is the template that we provide with the React VR CLI, but it's actually very functional. And what is more, I'm pretty confident that you would be able to take this code and push it way beyond, because all of it here is familiar with you. So I promised to talk through the uses of React VR in Oculus, where we use React VR to power a number of our first-party applications. So let's begin. Right, the first use of our React VR was actually integrating Facebook content into Oculus 360 photos. And there we needed to keep up with a sort of rapidly changing design. The use of React VR allowed us to change our workflow from a compile, run, and deploy to device of actually 3 minutes to 3 seconds. And it was very common for me to work for hours without having to rerun the application. And the workflow savings were incredible. It's this improvement factor that led to a more polished application. And the designers of 360 Photos were actually surprised how close we got to their Unity prototype. Next came the WebVR runtime. This was the first announced during the keynote of Oculus Connect 3, and we released a preview package for feedback in December last year. Based on that feedback, React VR was actually released to open source a month ago during F8. And since then, we've been sort of developing new features, accepting pull requests, and making bug fixes. So we, as a community, are maturing this framework together. And really, the team and I are very grateful for everyone who's contributed. So I'm going to say this now. Thank you very much. Next, as many of you know, Oculus recently released a new version of Oculus Home. And this was received in part because users benefited by 3 times faster boot up and actually 30% savings of power. But what you may not know is that Home was actually built entirely in React VR, and backed by a native runtime. The new full rewrite of Home was put together within a few months, and so the benefits were not just to our users, but actually our engineers too. And this was not just a one-off, this was actually repeated in the development of new photos and cinema applications. And these were a smaller team, and they were helped by being able to share the code across all of the applications. So we've covered a little bit of what we're doing with the native runtime. What about the WebVR framework that actually is in your hands today? Building on this technology, we sort of by the technology pioneered by the instant games teams at Facebook, we have made it incredibly easy to share React VR experiences directly within the FB newsfeed. Users will be presented with a 360 photo preview, and then tapping anywhere on that preview will launch a full screen experience. And then you'll be able to pan around the scene by using the phone's accelerometer, or maybe swipe to move the camera and explore. Ultimately, at its core, React VR, just like React and React Native, is built to support all platforms. The desire is the same experience written once will run on both iOS and Android smartphones, and then on any modern browser that supports WebGL, and all VR headsets via the WebVR-enabled browsers, and that includes Gear VR, Rift, but also Daydream and HTC Vive. So now Oculus have released Home, Focus and Cinema. I can gaze back and tell you what I think made it a success. First and foremost, it is the right framework for the right set of people. And when choosing your tools, you have to take this into account. But on top of that, all the teams gained developer tools they didn't previously possess. Hot reloading was critical, and when combined with the Chrome debugger, this became the workflow choice of all of our developers. In making hot reloading available in the first few weeks, we helped reduce the time to help make and test code changes, while the current state of the UI was maintained. These changes would be reflected on the device immediately. So, is anyone familiar out there with debugging native code, native C++ code on Android? If you're not, it's not a fun experience. So the Chrome debugger was actually a very welcome addition to fixing this. The React VR on Gear VR works in the same way as iOS and Android React Native, where the developer's machines run the JavaScript remotely, while the display and the native modules run on device. It's super effective and a good example of how we share solutions across the runtimes. Being in the world of React meant all the favorite JavaScript frameworks could be used. Handling of state management is a typical example. Relay was used to drive our GraphQL network queries, and Redux was used to help organize state. What I observed is that using these allowed teams to build on the collective knowledge of Facebook and play it to their advantage. It's like the who's who, this is. Stable applications require testing, and Jest was used in both snapshot and unit testing, so that gesture that we saw yesterday is happy. Using Flow for the static analysis for the JavaScript code has helped highlight those type issues. And we have implemented the basics of a WebDriver, which is allowing us to build an end-to-end test framework for React VR-based applications. Ultimately, React VR stands on the shoulders of such an amazing community. Many of the React Native and JavaScript packages will work actually with no or minimal effort. Okay, enough about how Oculus use React VR. So let's segue and delve deeper into the technical aspects of React VR, so you can make educated decisions on how best to use the web framework. First, I'm going to define a couple of terms. The runtime code, which is the equivalent of the Java in React Native Android, and runs on the main thread of the browser. And secondly, we have the React code, and this is the JavaScript code that contains JSX and describes the component hierarchy. So here we have a holistic view of our tech stack for Oculus React VR implementations. At the top, we have our application code, and this sits on the common React VR JavaScript. The goal is for this code to exist across multiple runtimes. It creates a layer of abstraction. Of course, there are capabilities of each platform, and that comes into play, but sharing of the source code across all of these is one of our constant concerns. Ultimately, I would like to handle the platform differences as runtime choices. And this is why all React VR applications come under the platform VR in the packager. Going a layer down, we have the native CPP runtime. This is the runtime used for the development of Home. But we're also in the process of integrating this into a number of other engines, so the benefits of React VR can be applied again for many more applications. Like React Native, JavaScript core is used on Android, but we also have a V8-based executor, which is used for Windows. The rendering is entirely custom, and there is no use of there's no platform views. We write everything for that by hand. And this has meant we can run on OpenGL, DirectX, and soon we'll have a Vulkan runtime. But there's always this emphasis on being flexible and portable and working across many, many devices. Now, the right of the diagram, we have our web implementation. This is a set of source code that was released during F8 last month. For the rendering, we use 3JS, which is used across many WebGL applications. In the future, we may abstract the rendering library. However, ultimately, our immediate focus is to realize what React VR can accomplish and really make decisions based on that. The JS and the CPU runtime do not share any code, and there's no use of any scripting. This is actually quite purposeful, and it allows us to avoid the sort of unnecessary interop across the various code barriers. We can play to the strength of JavaScript in this case. Unfortunately, it does come at the cost of re-implementation. For layout, Yoga is used, as many others are, and it's the same version we use for both JS and CPP runtimes. That actually is cross-compiled using scripting. This ensures that we have the same input. For the same input, we get the same placement of components in the React VR scene. Now, if you've looked into the WebVR runtime, you'll notice an interesting design choice. We actually make use of a web worker to run the React code alongside the runtime code. The app is actually effectively multi-threaded within a browser. And so multi-threading is standard practice for React Native, but it may come as a sort of like unusual choice for those coming from React DOM. But this is actually very purposeful, and one of the reasons React Native was chosen. So I'm just going to dig into this a little bit more. React Native works by passing messages between the runtime and the React code, and these messages describe the actions that need to be executed by routing messages to appropriate runtime modules and components. These two threads run asynchronously, as seen here. Whenever React code changes state, React Native needs to determine what has changed. And to do this, it runs a process known as reconciling. The calculated changes, any calls to native modules, are the messages. But computing this actually takes considerable time. But in VR, we have a hard constraint. We must render as fast as possible. Otherwise, people feel ill very quickly. And this is 60 hertz on mobile and 90 hertz on desktop. Rendering must happen from the runtime thread. So it's vital that we never, ever put roadblocks in the way. Now, it's unlikely we could ensure that the reconciling would always fit within the 16 milliseconds or less. So we actually by running this on a web worker, we actually hide that work. But the downside of running thread is that we introduce a latency as messages are pipelined between the runtime and the web worker. And it also means that native modules need to serialize the data that is passed. To a developer, this means you need to minimize the bulk data passed across the runtime to React code and vice versa. For example, describing a full 3D model as a native property is not ideal. A better way would be to use a URL or alternatively describe the once and then use a handle. But it's knowledge of this constraint that would help you plan your use of React VR to best fit your own requirements. As previously mentioned, the intention is for React VR to be as compatible as possible across many multiple runtimes. However, as more platforms have been brought online, we've learned that it's not always easy to support the vast array of possibilities. And Input is a good example of this area where we found the support of very different capabilities a challenge. For example, touch. The touch controller is a full 6 degree of freedom controller. You can move and position the orientation, and you can read that back actually within the browser. But if we take Gear VR or the Daydream controller, only the orientation can be used. So you're moving your wrist, but that's all the information you know and you can get. However, depending on the application, there is actually the potential for for applying a simulation to help determine that position. The way we solve this is to provide you, the developer, the APIs to make the best choices, and that's really the best way of achieving this goal. So you have your new React VR application. Let's go through some of the best practices. For 2D, we use cylinder panels. These panels are super important to simplifying the UI setup, as well as making it a UI comfortable in VR. The use of cylinder panels allows you to author your UI in a way that you can continue to use pixel placement, so those 2D skills are very valid. This leads actually also to better quality text and actually a much more comfortable user experience. To help demystify this a little bit, I've taken a capture of a web page and placed this on a panel. If you were to view this in VR, you would see that the height of the fonts, the dimensions of images appear the same as they would appear in a 2D page. You'd also find the text easier to read, as your eyes will not have to adapt to different distances as you scan the view in your headset. It's very simple to use. It's better quality. The only caveat is that the components are rendered onto a surface, and that means they can't pop out of the page. So let's look at it's very small, I'm sorry about that. Let's look at how we use the cylinder panel. In the code on the left, you'll see the cylindrical panel component. This is the placement of the object in the React VR world, and it contains the dimensions of the panel in pixels. After that, any child component of the cylindrical panel has its style dimensions specified in pixels, and really that is it. And you get the hit tests and the input work with absolutely no change. So it's very, very simple to use and very effective. I encourage you to actually play around with this. You'll notice the jump in quality. Now, fonts are always a challenge in VR. In VR, they're even more so. Unfortunately, we can't make use of the browser font technology. Bitmap fonts work, and Bitmap's fonts work great when the font map is 1-to-1 in screen pixels. However, they look bad when rotated or scaled, and this is exactly what happens in VR. And within React VR, you can actually place a text component anywhere in the scene. You have full control of the transform. So for React VR, we've implemented our own solution. It's based on signed distance field fonts. Signed distance field font training was made popular after the use in Team Fortress 2, and allows a small image to be used across a large scale range. Here's an example of a signed distance field character. You'll notice the gradient on the image, and the brightness here is actually used to indicate the proximity to the edge of the character. And when rendered on the GPU with a shader, it allows the edge to be crisp regardless of the scale or rotation. So on your left, you'll see the scaled up bitmap glyph, and then on the right, you'll see a scaled up signed distance glyph. It's an extreme example, but now you probably understand why we use them. However, they're expensive to calculate, and they require tools, which means the large downloads for when you start using large character sets. But what is awesome actually is we're just about to make the tools available to generate your own fonts, and this will allow you to put the sort of typography, the control of the fonts, and download requirements in your own hands. A new space brings new media types. And so I'm going to focus on the model components. And in React VR, the default geometry format is wavefront OBJ files. But these are very basic, and for this reason, we allowed 3D geometry to be extended in the client. And here's the steps. First, you implement a model instance that obeys a flow interface. The model instance is responsible for looking after the mesh used by 3JS. Next, you implement the model loader, and again, a flow interface is used to ensure that this is correct. A model loader is registered and is responsible for creating an instance based on the source attribute of the model component. These interfaces are enough to create some fantastic functionality, and as I'll show you. So all these could be supported with React VR by following the instructions on the previous slide. Imagine being able to look at the molecules. You could be in the middle of the atoms. Particle systems could be used to model the solar system. Or you could be viewing 3D printer models in VR prior to committing to printing them. And finally, this one actually, that one doesn't come up very well, but the point clouds could be used to visualize all the LiDAR data that is readily available on the internet. Super, it's geeky, but it's something that's really quite passionate for me. All these are available in the browser in VR. I'm going to have to skip through this quite quickly, but performance is a complex thing when you run at over 60 hertz per second, and rendering can be due to GPU or CPU. So you have to get a number of steps to go through. The GPU can have a couple of problems, and for the first one, I'll focus on fill rate. This is the time to draw each little pixel on screen, and it's a common problem for laptops. To test this, the best thing you can do is actually downsize the browser and observe if the frame rate improves. One way of solving this is to introduce the pixel ratio when creating the VR instance. A lower value will reduce the number of pixels rendered. Another reason for low frame rates is drawing too many polygons. For example, if you've got multiple heavy tessellated spheres in a scene, testing this is a little bit harder because it generally involves altering the scene by using a lower polygon mesh. But if you're not aware, MeshLab is a fantastic tool for reducing polygon content, and that's available free. Finally, this brings us to CPU. Well, Chrome has a fabulous set of tools, and you should use them. The simple profile capture interaction with your application will reveal a wealth of information and help inform your optimizations. But beware, React Native has many debug checks when running in dev mode, so be careful to test in the prod build of your JavaScript bundle. Tomorrow, we have a hackathon, and I'll be there. I'll be hacking myself, and I've got some ideas. But Oculus have put up a Gear VR and a controller signed by Michael Antonoff, one of the Oculus's founders, as a prize. And 360 Cities have also made available a free choice of 6 cube maps from their vast collection for the use in the hack. So take this down. But I want to inspire you a little bit more. Here's a game of social VR chess. This runs in Newsfeed and was put together by one of my co-workers over a weekend. You can play in or even out of VR on desktop or even mobile, connecting to your friends and challenging them. I honestly think this is super exciting and would love to see what actually you folks put together. So go experiment. I'll leave you with this, but know that you have VR within your grasp in well within 100 characters. Have a look at the developer portal. You find much more information there. There's some other examples of the use of React VR. Thank you for listening. Thank you for the organizers for this great conference. I'll be around later and tomorrow at the hackathon for questions, thoughts, and hopefully your feedback. Thank you.